All right, so today's lessons on 1-3 is quite a bit shorter than 1-2, to say the least. So a couple of things. You'll probably want a highlighter and a color or two. There are 12 basic functions in precalculus that you're going to use both in precalculus and calculus. You need to be very familiar with these functions. So if I were you, I would put each of these on a flashcard and know all of their different characteristics. What is the domain? What is the range? Is it continuous? Is it discontinuous? Is it an even or an odd function? Meaning, is it symmetric to the y-axis or the origin? Is, what else could we do? Where is it increasing? Where is it decreasing? All that kind of stuff. Everything that we've talked about up until now. So nothing is new in 1-3. Is it bounded? So that was another one that we talked about. So I'm not going to go through absolutely everything in all these graphs, but I'm going to talk a lot about them. And then you've got a couple of examples that you're going to do on your own. So the first graph is your x cubed graph. It's the cubing function. And I did put in here that it is an odd function. And it's an odd function because, as you can see, it is symmetrical to the origin. If I take this part right here and I reflect it across the y-axis, it would look like that. And if I reflect this across the x-axis, it would actually be here. So it is symmetric to the origin. What is the domain? Going from left to right, what's the domain of this function? Negative infinity. Zero. It goes past zero, right? You have x values here that are over here, so it goes to positive infinity, doesn't it? So the domain goes from negative infinity to positive infinity. Although this might look like a horizontal asymptote at x equals 2, it will be very clear as to whether there's an asymptote or not. And just plug in a value that's bigger than 2, like 3. You can take 3 and cube it and get a y value, can't you? So you know that this is going to continue on and on. I can cube any number I want to and come up with a value. And I can get a positive or a negative value for that. So what is my range? Is it restricted? Is my range restricted? Yay or nay? Go from low to high. Lowest range value is what? Negative infinity to positive infinity. There's no values that are skipped. So it also goes from negative infinity to positive infinity. Is this continuous? Are there any breaks in the graph at all? Any jumps to make? Nope, it's continuous. It's one nice smooth graph. Continuous means you're jumping from one portion of the graph to get to the other. You have to literally make a leap to get there. Okay, so then let's look at the reciprocal function. F of x equals 1 over x. I did put on here that it is discontinuous. So here's an example of where, if I'm on this part of the graph, I have to jump to get to that part of the graph, don't I? So it is discontinuous. It is an odd function because if I were to reflect it over the y-axis, it would look like this, would it not? And then if I were to reflect this over the x-axis, I would actually get that curve there. And those curves are in diagonal quadrants to each other. So it is definitely symmetrical to the origin. Then let's talk about domain and range. Can a denominator be any number we can think of? Because that's where the x is. No, what can it not be? And notice that there appears to be a vertical asymptote here, doesn't there? And that vertical asymptote is x equals 0. Does there appear to be another asymptote?
Y equals 0.
Y equals 0. So that y restricts the domain. Y restricts the range. X equals restricts domain, y equals restricts range. X is domain, y is range. So that means that I can have x any number I want to, but I have to leap over that asymptote to get to the other x's. So when it's discontinuous, it's a big clue that there's a restriction on domain and or range. So our leftmost domain is what? Negative infinity. 2, we approach 0, but we do not include 0, so that's parentheses there. Union, then I start again at 0, but don't include it and go to what? Positive infinity. your range is going to look identical because our lowest range is negative infinity. We come to 0, we have to leap over it, and we go to positive infinity on the y side. So it also is identical to the domain. Is this graph bounded? Overall, is this graph bounded? Does it have an overall low or overall high? No. So it's not bounded. That's a question I could ask you. Although if we restricted it, then it becomes bounded, right? How? Is there a definite high? Remember, this is one of those weird ones. They say it's bounded above because there's a, yeah, but they consider that this is a max, relatively. And then this would be bounded where? Where? Below, right? Because it's got a bottom to it. Is this one bounded? No, it's not bounded. All right, let's look at the square root function. The square root function, part of the graph is missing, right? Can you take the square root of any number that you can think of? No, what kind of numbers can you not take the square root of? Negatives. Can you take the square root of 0? Yes, it's 0. So this ordered pair right here, 0, 0, is part of the domain and the range. Quincy, are you with me?
Yeah.
Pay attention. You should be writing stuff down. And you're fiddling. You're fiddling. I'm talking about this one now. You've missed it.
Okay.
All right, so my domain, what is my smallest domain number from left to right? What's the first domain I come to? X value. 0. Does it include 0? Yes, because 0, 0 is an x value on the graph, right? 0 is part of that 0, 0 point. And it goes to, what's happening here? It's going to infinity, right? Is the range exactly the same or is it different? What's our lowest range value? 0 and goes infinity. And if you think about it, the output, f of x, can only be a positive answer or 0. So we've got a range that also includes 0 and goes to infinity. So all three of these examples have had exactly the same domain and range restriction. That's not always the case. Is this a continuous function? Yes or no? Yes, it is. Do you see any asymptotes? No. Okay. Exponential function. This is one that you're going to become quite familiar with once we get to logs. But you might remember this from Algebra 3-4. E is a number just like pi. It's an irrational number. It is a decimal that does not end or repeat. Is there any way, because x's are domain, is there any way you can't raise a base to any type of exponent I want to, negative, positive, 0? Is there any restrictions on this domain? Your leftmost x value, this is implying that it's going infinitely in this direction, isn't it? So my leftmost x value is negative infinity. My rightmost x value, doesn't it get bigger and bigger and bigger? The bigger this exponent is, the bigger that number is going to become. And so it goes to positive infinity. There is no vertical asymptote there. However, even if I put a negative number in for this exponent, a negative value here, notice that y is still positive because a negative exponent does not mean the value of that power is negative. What does it mean? Take the reciprocal, right? So if this were e to the negative 2, it really means 1 over e squared. And that's just going to be a really small number between 1 and 0. So there's no way for this value to be negative. So the range goes from 0, does it include 0? Is there any way for that power to be 0? Can I make that exponent a number that would create a 0 for value? Most of you would say e to the 0. Well, what's anything to the 0 power? Nope. 1. Anything to the 0 power is 1. So there is nothing that I can put in for x that would create a value for that power of 0. Nothing. And so 0 is not included. But we will go to positive infinity. So here's an example where domain and range restrictions are different.
Why wouldn't the 0 have a bracket?
Because if I put 0 in for x, first of all, 0, 0 is not an ordered pair on that graph.
Okay.
And most of you were feeling that, well, the only way to make this 0 would be if x were 0. Well, If x were 0, that means that the value of the function is 1, which anything with 0 power is 1. So there's no value even down here where a y value has a value of 0 in those ordered pairs. It gets close, really, really close, but it never actually hits 0, which is why we have this asymptote y equals 0 there. Okay, so let's look at the logarithmic function, the natural log function. Very similar to the exponential function, but it's been reflected. Now I want you to take your calculator, because it looks like it's approaching x equals 0 here, doesn't it? Okay, so let's take our calculator and let's try to take the natural log of x. So your natural log button's right here. So natural log of x, oh not of x, natural log of 0, sorry. Try to get that glare off. There we go. Natural log of 0, can you take it? Interesting thing occurs, you get an error message that says domain. Isn't domain x values? So they're implying that you put a wrong x value in there. You cannot take the natural log of 0. It's impossible. We'll explore natural logs a whole lot more later. But this is an asymptote. Vertical asymptotes restrict what? The domain or the range? It goes through what axis? The x-axis. It goes through the x-axis. So therefore it restricts the domain because it's going through the x-axis. And so my leftmost number is 0, but do we include 0? No, so it's a parentheses this time. Because there's no ordered pair of 0, 0. I just proved to you you can't have an x value of 0. It's undefined. But we are going to the right to what number? What's my right bound number? Infinity. What about the range? Is the range restricted at all? Not at all. The range goes from negative infinity. You can come up with a negative value for y. You can have 0 for y. When x is 1, the natural log will actually be 0, and then you can have a positive value. So the range goes from negative infinity to positive infinity. So aren't these just the reverse of each other? Yep. They're both continuous, correct? Okay. Sine function. Now let's talk about a more refined definition of bounded, now that we get the concept of what bounded is, right? Bounded, for a graph to be bounded, that looks like this. Because we had one where we had an endpoint here and an endpoint there, and we said that that was bounded, correct? But this one has infinite right and left-hand behavior. A graph is bounded if it is bounded between two horizontal asymptotes. And you will become very familiar with the sine and the cosine functions, which we're going to look at here in a minute. They do have sort of a horizontal axis. It's not exactly a horizontal asymptote because it actually touches y equals 1. And it actually touches y equals negative 1. But it is bounded between those two horizontal lines. It's not truly an asymptote in the sense of asymptotes, but it is bounded by those two horizontal lines. So consider it horizontal lines. I guess would be better than asymptotes. Maybe we'll change that. It could be asymptotes. It could be just a line like this one is. That tape is the two horizontal lines. So, horizontal lines go through what axis? The y-axis. So it's going to restrict domain or range. Range, because range is 1. So is the domain restricted at all? No. So your domain is negative infinity to positive infinity, but your range is restricted from low to high negative 1 to 1. And I am telling you it is including negative 1 and 1. And you'll see why that is when we study the unit circle, which you might remember from last year. So this is bounded both above and below. That's why it's just bounded. It is an odd function because it is symmetrical to the origin. So if you were just to take this part of the graph, I could reflect this over the y-axis and then reflect that over the x-axis, and you would get just that part. You can reflect the entire graph, but it's easier just to look at a piece of it. All right, so let's flip that. The cosine function looks somewhat similar to the sine function. It also is bounded by y equals 1 and y equals negative 1. So its domain and range is exactly the same as the sine function. So domain is negative infinity to positive infinity, and range includes negative 1 to 1. What is the difference between the sine and the cosine? Oh, by the way, the cosine is an even function. It is symmetrical with respect to the y-axis, whereas the sine function is symmetrical with respect to the origin. How are they different? They look very much alike. How are they different? Focus on perhaps an ordered pair that makes them different. Okay. So on the cosine function, there is a maximum here at 0, 1. Whereas on the sine function, that same ordered pair, that same place, is 0, 0. In other words, the sine function starts at a y value of 0, whereas the cosine function starts at a y value of 1 on the y-axis. There's your difference. The shape of the graphs are identical, but this one I can fold at the y-axis and it folds onto itself, making it even. Whereas, put that on this one is odd. So make sure that you know those differences. Is that a continuous function? Are there any breaks in it? Any jumps? Any holes? No, so it's continuous. Absolute value function. It is considered an even function. Note that it is symmetrical to the y-axis, that's why it's even. Is it bounded? Yes, where? Below. Isn't it bounded below? Yeah. Domain. Is the domain restricted? Can you take the absolute value of any x value that you want? Can you put any number in there for x? Yeah, positive, negative, 0. What are you going to get? You get only a positive number or 0, right? So the y is restricted, not the x. So x is unrestricted from negative infinity to positive infinity. But the range, what is the first range value? That you come to 0. Do we include 0? Yes, 0, 0 is a point on that graph, and it goes on to positive infinity. The greatest integer function is one of the greatest pain in the butts function for you all. It can get very confusing. It's a step function also known as that. So basically I'm stepping from here to here to here to here to here. That's why it's discontinuous, because you have to keep stepping or jumping or leaping to get to the next part of the graph. But the domain and range are very interesting in this one. Can you pick any value you want to for x? Let's say that I pick 5.5. Well, 5.5 would fall here at a y of negative 5. But you go, okay, there's a hole here at negative 4. But to pick negative 4, that means I'm now on this step, right? It has a y value of negative 4. So I can pick any value I want to for x, positive, negative, 0, decimal, fraction, it doesn't matter. Your domain is unrestricted on the greatest integer function. But what's going on with the y? Step, step, step. What kind of values are coming out? What kind of answers are there on this graph for the y? Look at your y values. -5, -4, -3, -2, -1, 0, 1, 2, 3. What values are those? What kind of numbers? They're not real, well, they are part of the real number set, but what specific number set are they? They're not whole numbers, they're integers, right? Because you got negatives in there too. So the range is actually restricted to the set of integers. So that's a weird one. The logistic function, which is a tad bit complicated looking, is 1 over 1 plus e to the negative x. Is there any way for this fraction to become 0? What part of the fraction determines whether it's 0? The numerator or the denominator? The numerator. Is there any variable in the numerator? There's no way for this fraction to have a value of 0. So y cannot be 0. Do you see that it is approaching the x-axis, which is y equals 0? That's a horizontal asymptote, meaning it's restricting the range. And they're telling you right here that y equals 1 is another horizontal asymptote. So like sine and cosine, this logistic function is restricted at the range, but it's restricted from 0 to 1. Does it include 0 or 1? Unlike the sine and cosine function. Does it include that? Can the value of this ever be 1? That means that this power would have to be 0 for the value of the function, or that fraction to be 1. What do we talk about? This. Remember, this is on the other side. E to the x. Can e to the x ever have a value of 0? Even though it's e to the negative x, it still can't. There's nothing I can put in for x here to make this have a value, that power have a value of 0. So there's no way for the fraction to be exactly 1. So 0 and 1 are not included. Your domain is unrestricted, but your range is restricted from 0 to 1, but not including that. Because those are both asymptotes, true asymptotes. Is this continuous? Yes or no? Yes. It is bounded. Why? That means above and below it's bounded. Why? Not they eventually meet. They're bounded between what? 2 lines, aren't they? 2 horizontal lines. So that's all they need to be bounded. That implies both above and below. All right, almost there. The identity function. So these are actually the first 2 functions, but this is where they fit on the paper, so I didn't have to do 3 pages. Identity function meaning y equals x. Every ordered pair on this line, the x and the y values are identical. 1, 1, 2, 2, 3, 3, -1, -1, -2, -2, etc. So that's why they call it the identity function. Is it continuous? Yes or no? Yep. Is it, it's an odd function. Why? Yeah, it's symmetrical. If I take just the part from 0 to infinity, just that part and reflect it over the y-axis, I get that. And if I reflect that part over the x-axis, doesn't end up over here. You might not have thought about this, but it is symmetric to the origin. And notice that they are in opposite quadrants to each other. The domain is unrestricted. The range is unrestricted. The squaring function, that is an even function because it is symmetrical to the y-axis. What's the domain? So it is unrestricted. And the range, what's the lowest range value come to? 0. Does it include 0? Is a y value of 0 on an ordered pair there? Isn't that 0, 0, the origin, right? So it does have a y value of 0. So we are going to include it, and it does go to cos infinity. Okay, so know those. The only difference that there's going to be on your homework is they're going to take these general equations and they're going to add and subtract things to them, or put a coefficient in front of like the x squared or something like that to stretch it vertically or shrink it horizontally. And so your domain and range might change because they translated it. So you need to graph it on your calculator. So put in your calculator how you see it, and then answer the questions based upon that. So that's the only difference that you're going to see in your homework. So come with questions tomorrow. Tomorrow we're going directly into the math lab. And so you should have questions for me. You should be through 1-3. It goes pretty quickly tonight. It's really a lot of just what we did here. Questions that they ask you about the graph. So I put here for you, analyzing graphs, functions graphically. These are the basic questions that you're going to be asked. Extremas relate to maximums and mins. Is the function odd, even, or neither? Where is it increasing, decreasing? We didn't talk a lot about that, but we will here. I didn't put on here, but is the function bounded? How does the graph relate to the graph of the basic function? That's where you're going to have to compare it to what we just did here. How has it been translated? And so those are pretty much the questions that you're going to end up having tomorrow on your homework. So let's look at this one. F of x is equal to the square root of x. So those of you who don't have your calculator and you don't want to flip, I'm going to put that into my y equals. So we did the absolute values under your math button, under numbers, and x. All right, so that's your graph. I want you to answer these questions right here. And these are things that we've done all last week. I want you to answer those questions on your own, and then we'll compare and see how you did. Stats plot. Then once you have all the questions answered, I want you to compare them with people around you to see if they agree with you. Say that again? Yeah.
About the graphs on the
It's whether it has a match or not.
Why?
Does it have a match or not? Okay. Has a min. So, so is that min? Is that at the bottom of the graph or the top of the graph? Bottom. So it's below. Even though the whole graph is above the x-axis.
It's bound, so it's not bounded.
It is bounded. It has a min. It still would be bounded. But it would be above.
No.
So if there was no min-max, it would be a bounded.
No, right. She doesn't have her phone.
Like the cubic function.
She does.
That's not
No.
bounded.
So
She does. Like,
this would be bounded to the min-max, right?
Correct. Well, yes, but it's bounded because of that one's between two horizontal lines.
Okay. So
This one's not between any horizontal lines, but and that bounded
It's weird.
implies that it's both above and below. When you just say bounded, it implies it's above and below. That's why that one's bounded.
Is that where Tuesday
This one's bounded below because
Don't you
there's
work
just
the
a
base?
This one's unbounded to the min-max.
Right.
So it has min-max bounded. If it's a minimum, it's bounded below. Maximum's bounded below.
Correct.
Thank you.
It's like none of us really can. But are you recording?
You guys are supposed to be talking about your problem, not Friday nights. So chat, compare to other.
Buckman,
other-
coming over.
No, you're not coming over. Stay and put no.
Yeah, our stairs was really big.
Bless you. Thank you.
Hey, the big Texas and I guess.
All right, so here are the answers. Do you have questions on how I wrote some of these? Like especially the, notice how I wrote the minimum. Recall that the minimum is really the y value. It's not an ordered pair. It depends on how the question is asked. And so the minimum is actually the y value of the ordered pair at which that minimum occurs. Same thing with the maximum. Would be the y value. And the minimum is going to, the min or the max restricts the domain. So, I'm sorry, I just said that totally backwards. The min or the max restricts the range. And so you see here that the domain is unrestricted. And the range, the lowest value it starts at is 0 because 0, 0 is an ordered pair, and that happens to be the minimum ordered pair. The y value is 0, and that's where your range starts from 0 to positive infinity. It is decreasing as we go from left to right. At negative infinity, we go top down, which means it's decreasing. So from negative infinity to 0, it's decreasing. Then from 0 to positive infinity, it's going from bottom up, so it's increasing. Now, you might have found in Math Excel that sometimes they won't accept it unless you have brackets, and sometimes they won't. The questions themselves ask you with parentheses. So you need to understand that if it's included, you need to use brackets. They're a little inconsistent on that. And I think it's because they're trying to, I don't know, trick you. Yeah. All right, so it is symmetrical with respect to the y-axis, which makes it even. It is bounded below because it has a minimum, not because it has nothing to do with whether it's above the x-axis or not. There are no horizontal or vertical asymptotes. This does not count as a horizontal asymptote just because it's going to a minimum. The graph is not approaching any particular horizontal lines. And then end behavior. So remember end behavior, I'm getting you used to that limit notation. The limit as x approaches infinity. So as x approaches infinity, we're going backwards this way. As x is, positive infinity, we're going forwards this way. What's happening to the graph? Is it going up or down? This graph is going up, so the right-hand behavior means it's going infinitely towards positive infinity. And as we go backwards towards negative infinity, the graph is again going up. So the left hand and the right hand behavior both agree they're both going in the same direction. All right, then the last piece that we're going to look at is the piecewise function. And you need to realize that this does not belong, but it was impossible for me to take it off on the computer last night, so it wouldn't accept it otherwise. So take that off, and then this is 0. So that's really what it looks like. You have to graph the part of the x squared graph that has x values that are less than or equal to 0. And the part of the square root of x graph that has x values that are just greater than 0. So if I were to graph the square root function by itself, I'm going to use a pencil because we might have to erase parts of it. I'm going to start plugging in values, starting at, this is my boundary point. So even though we don't include 0, you still need to figure out what it would have equaled if it did include 0. Can I take the square root of 0? Yes, it's 0. But it's not equals to, so we're going to put an open circle at 0. Then, can I take the square root of my next integer, because I'm going greater than 0, next integer greater than 0 is 1. So can I take the square root of 1? It's 1. So 1, 1 is an order pair I'm going to plot. I cannot take the square root of 2. It's not a nice number, so I'm going to skip it. Can't take the square root of 3, skip it. I can take the square root of 4, which is 2. So my other order pair is 4, 2 here. So I'm going to connect from the open circle out infinitely to the right. So that represents the square root of x for the values of x that are greater than 0. I have that open circle there. Then I'm going to plot x squared. So again, my boundary point is 0. So I'm going to start at 0, and this time I include 0. So if I take 0 and square it, what do I get? 0. So it's actually this ordered pair. Wouldn't I fill in that open circle? If for some reason, and some of your piecewise graphs are going to look like this, if for some reason when I squared the number it turned out to be 2, you would just have a solid dot up here at 2. But notice that every part of the domain is being covered at some point. And so that would end up being a jump function, wouldn't it? But in this case, it's not. So we're going to fill in that circle. And I'm going less than 0. So my next number integer to the left is -1. Well, -1 squared is +1. My next integer to the left is -2. -2 squared is +4. And that's as far as I can go. So then I'm going to connect that. And that's what that piecewise function graph looks like. And then they're going to ask you a bunch of questions. Is it continuous? Yes or no? Yes. Yeah, so it's continuous. What is the domain? Leftmost number would be what? -infinity to... Yep, so it's unrestricted. I can choose any number and there'll be a y. Is the y restricted? Is the range restricted? What's the lowest range I hit? 0, and I go to +infinity. Do I include 0? Yes, I do. Is this an even function? Or an odd function? Is it symmetrical to the y-axis or to the origin? No, it definitely is not. Is it bounded? Below the graph, right? What about the end behavior? As I approach x, as x approaches infinity, what's happening to the end behavior? What's happening to the y value? It's increasing, so it's approaching infinity. So it looked like this. As I approach negative infinity, what's happening to the end behavior? It's approaching infinity. So again, the left and right hand behavior for this graph looks just like this, with the exception we put the piecewise graph. Questions in general on today's lesson? What is it that you're responsible for knowing by heart by Wednesday? It's all these different functions, which you had all of these in Algebra 3-4, oh, by the way. I know for a fact you had them. You may not remember them, so you might have to review them again.